Good day. Happy whatever day it is. Today we're going to talk about lesson 4.4, which is all about the idea of humidity. And most of us think of humidity just as that nasty, muggy feeling that we get when we go outside here in the summer. However, humidity goes both directions. It's both high and low humidity. And when we talk about humidity, what we focus on is the fact that humidity tells us how much water is present in the air around us and in the atmosphere. So there's really two types of humidity that we're going to focus on. One is relative humidity and the other is specific humidity. Relative humidity is a ratio. So relative is usually going to mean in comparison to. So for relative humidity, what we're going to do is compare how much water we have present in the atmosphere or in the air to how much we could possibly have. So the maximum amount the air can hold. So again, relative humidity is how much we actually have over how much is possible to fit in there. So if we had an empty glass or an empty jug of some sort that could hold 10 liters of liquid, the relative humidity would be how much we actually pour into it divided by those 10 liters. And the same can be said for the air and how we measure the humidity in the air. Now, even though relative humidity is going to be a proportion of two things, a comparison, specific humidity is exactly what it sounds like. It's the actual amount of humidity in the air. Now, as we move forward, when the temperature changes from hot to cold, we see that hot air is going to be more expanded. It's going to be more spread out. So these 4 dots of water are going to have more space, which means that overall, hot air can hold more moisture than cold air because cold air is going to be more densely packed and have less open space for water to fit into. When water continues to fill and fill and fill the air, or the humidity gets higher, we have what we call saturation, and that's when we have as much as possible. That would be when this entire space here is filled with water molecules. Or if you want to go back to that jug analogy, when the entire jug would be filled with water, our air would be saturated. It would be completely humid. So if we were to completely saturate hot air, we would have more water than if we completely saturated the cold air. Now, one thing that really relates to us, and it goes back to how I introduced this, is when we have very, very high humidity, the water is going to feel, or the air, is going to feel much hotter. So that would be like the summer. We already have heat, but then you add in the high humidity and it feels hotter than it actually is. When you have low humidity, even that hotness will feel more cool. So Colorado at 90 degrees, where there's not very much humidity, actually feels less hot than it does here in North Carolina, where there's high humidity. So what you're really going to see in this unit on the tests, on the quizzes, is the interplay between temperature, humidity, temperature in air, temperature in the atmosphere. So make sure as you're going through these notes, as we're going through these things in lectures, as we're going through activities and experiments, you're constantly thinking about how the air would change with hot or cold temperatures going along with it. And the last little tidbit that goes with that is what we call the dew point, D-E-W point. The dew point is the temperature of the air when water is going to condense. So we talked about condensation quite a bit when we talked about the water cycle. But now if we just have freestanding water in the air, so some form of humidity, the dew point is going to be that point, that lowering of the temperature when the evaporated water suddenly can condense again into a solid form. That's what you see on your windshields oftentimes in the morning, as well as the grass, the sidewalks, the concrete, everything. So again, we went through relative and specific humidity. We talked about how relative is a proportion and specific is only one value. We compared hot and cold air based on how much humidity they can hold, how much water they can hold. And then we discussed how temperature would affect the overall feel or the heat index of our atmosphere and our air.